Okay, so this is 2.3. This is on page M232. In your last set of notes, what you were looking at is we were talking about if someone was going faster, or if Jack and Jill were going faster, what would happen to this line. So we said if they were going faster, it would be like going up quicker, and if they were going slower, that's this line that I erased right here, it would have been like this. So I always think of that as like more flat and then more steep. So it's going up quicker. This one's not going up as fast. That's what they were going. So what that is actually called is slope. And so I've already written out the definition for slope. So slope describes the direction and steepness of a line. Typically we use m as the variable. And it is the same thing as rate of change. So you're going to constantly hear us talk about slope, rate of change, all of that. They're the same thing. So slope and rate of change, they're the same. The way I remember the word slope, I'm always trying to find ways for myself and my students, and so for you guys, is slope. So when you think of hitting the slopes, what you think of is a mountain. So M, mountain, slope, we use the letter M. So I draw the letter M for mountain. And I remember, sorry, you can probably hear the fan, I'm really cold. But so you think about the mountain, and we have snow at the top of our mountain. And so when you're hitting the slopes, here's my little guy, and he's skiing. He's going down the slopes. And he's going down the steep part, because it's not fun to go uphill. So he's going down this steep part. So it's the steepness of the mountain. Okay, so that's the way I remember it. So I think about a mountain, mountain, hitting the slopes of a mountain. Sorry, my son is being loud. I'm going to tap on the wall. Okay, so when we go back over here to 2.3, so Jack and Jill's Aunt Mary lives 10 yards from their home closer to the bus stop. After spending Monday night at Aunt Mary's house, they leave for the bus stop from there Tuesday morning. They walk the same rate, 4 yards every 3 seconds. The graph shows the line. So this is that line we drew the other day where it was going 3 feet in 4 seconds. Notice that's the same line. So now we're going to talk about the two situations. So if they're going the same rate, but let's look at it and say, so if they're going to start at 10 yards. So if I wanted to graph this line, so Jack and Jill, instead of starting from home when they were distance 0 from home, they're at their Aunt Mary's house, and so they're going to start 10 yards away from home. So do you think it's going to be faster or slower to get to the bus stop? Are they going to get to the bus stop quicker? Okay, but remember, they're still going 4 yards every 3 seconds. So they're still going the same rate, and we're going to talk about that in just a minute. But let's look, actually, you know what, I changed my mind. We're going to fill in this table first. So we're going to mark this part out again and this part out again. So they're going to go the same distance, but where did they start? So how do the starting points compare? When they stayed at home, they were 0 feet from home. When they stay at their aunt's house, they're 10 feet from the starting point. So they're going to be, 10 yards. So they're going to be 10 yards away from home already. That's when they started, because they started away from their house. They started at their aunt's house. So 0 time spent, they started 10 yards away. But they're still going to go in the same rate. So notice this went up by 3. So if it went up 3 seconds, notice it's going to go up by 4 yards. So 10 plus 4 would be 14. Then we're going to go up 4 more. 14 plus 4 would be 18. 18 plus 4 more. 18, 19, 20, 21, 22. So they would be 22 yards away. Notice it's still 10 feet or 10 yards further ahead because they're going at the same rate. So let's go ahead and graph that. So I'm going to zoom my camera out. I know it's going to be harder to see, but I want you to be able to see this over here. So we're going to use green. So they started at 10 feet, and then they're going to go up 4. So they're going to go up. Notice this is 10, this is 11, 12, 13. So pay attention to that. So they're going up 4 in 3 seconds. So that's where my point would be. So there we go. Okay, so that's there. Now we need to go up to 6, and we need to be at 18. So remember, we're looking at this point right here. So 6 is the time, 18 is the yard. So 6 to 18. So we're going to plot that point right there. Then we're going to do 22. So we're going to go over to 9. Ooh, 22 is not on there. So we're just going to have to use our note card or whatever straight object you're going to use, and you're going to mark that line. Now, if you look at those 2 lines, and now we're going to look back at, what these are talking about. So the slope. So the steepness of this line, if you look at those 2, what do you notice? So remember us using patty paper. Here's my y-axis. That's not very straight. There's my x-axis. There's our original line. So if we have our original line, and now we move up to this one, what do you notice about those 2 lines? Are they the same steepness, or is one steeper than the other? Well, they have the same steepness. Remember, we just said in our notebook that slope is the same as the rate of change. So if they have the same slope of, same rate of 4/3, then that means the slopes are the same. Same rate, same slope. If you look, this one up 4, this one up 4, this one up 4. So both of those are going up by the same amount. The only thing that was different is that they started at a different spot. So instead of starting at 0, they started at 10. So I traced on the piece of patty paper. You don't have to do it, you just watched. Then we translated the line to represent their walk. We did that. And analyze the translated line. So how does this translation affect the unit rate? It didn't. It did not affect the rates and slope were the same. Okay, so again, all we're wanting you to see on this one is that they're not starting at 0, 0, they started at 10, but they still had the same steepness. See my air quotes. They had the same steepness. They both went up 4. They both went up 4 and over to that 3 mark. They both went up 4 and over to that 3 mark. So that was the learning outcome, or whatever you want to call it, for this, is that you could see that they had the same slope, so the lines looked the same, but instead of it starting at the origin, is what we call 0, 0, it starts up higher.